All right, guys, we're going to continue our exponent rules where we multiply a polynomial. Now, the polynomial is just an expression that has multiple terms. So before, even though we had lots of x's and y's together with the coefficient most of the time, that's not necessarily a polynomial. So each term is separated by a plus or a minus sign. So since we didn't have any plus or minus signs in our expressions before when we looked at exponent rules, we're going to see multiple term expressions where we are going to multiply there. Now, you have seen this method in biology already with FOIL. Now, what we're going to probably change a little bit, and I'm not sure if you've covered this in biology, is what happens if you have a 3-term times a 2-term. And so a 3-term polynomial is called a trinomial, and a 2-term polynomial is called a binomial. So the first thing that we're going to show you or talk about is FOIL. So that's first, outside, inside, last. And there you can see the multiplication through. And then you want to combine the two like terms, which are going to be the 3x and the 12x, negative 3x plus a 12x, which makes that, let's see here. Let's see if I get that right. Okay. And so that is going to lead you to the 9x, positive 9x there. So those are your like terms. So remember, we talked about that at the very beginning of the year where you have the same base, so same variable to the same power. Those are your like terms, and they can get together. Now, that only applies through addition and subtraction. So remember, with multiplication, like with our exponent rules, you didn't have to worry about the like terms necessarily. They all multiply out. But with adding and subtracting, they have to be like terms. So after I multiply here, this is going to be my product here, 2x squared plus 9x minus 18. So let's take a look. So I'm going to do the first times the first, so 5x times x. So that's like a 1 and a 1. So remember, if I multiply, I'm going to add those. So that becomes 5x squared. And then I'm going to do outside, which is 5x, and a negative 2, which is going to be a negative 10x. And then inside, which is going to be a positive 9x. And then last is going to be a negative 18. Here are my like terms right here. They can get together. They have the same variable to the same power. So they both have x, and they both have a 1 there. So therefore, I'm left with 5x squared minus 1x, or just x. So I drew that as a ghost 1 is what I like to call it, because it's there, but you don't always necessarily see it. And then you have minus 18 last. So that would be your product there with those two binomials. The next example, we have a trinomial times a binomial. So what you want to do here is you're basically just going to distribute everything, whether you distribute from the first trinomial, or if you decide to distribute from the x plus 2 binomial. I'm just going to start left to right, work my way over. So 6x squared times x makes 6x to the third, and then 6x squared times 2 is going to make a positive 12x squared. Then I'm going to have 5x times x, which is going to be a positive 5x squared. And then I'm going to have 5x times 2, which makes a positive 10x. And then lastly, I'm going to have negative 3 times x, which is a negative 3x, and negative 3 times 2, which is going to make a negative 6. So now I have all my terms there. I also have like terms. I actually have two pairs, I guess you would say. So I have a set here, and then I also have a set here. So I'm going to be left with 6x to the third power. There's nothing that gets with that. Then I have the 12x squared plus 5x squared, which is going to make a positive 17x squared. So remember, what I'm adding, I'm not going to add those exponents. Okay, they just stay the same. And then I have a 10x minus 3x, which is going to be a positive 7x, so plus 7x. And then I should have a minus 6. There's nothing that can get with. So here is going to be my product there. So like just a double distributing. So same thing here that we have. So I'm just going to start off with the front, and I'm just going to distribute through. So I'm going to have 3x squared times x. That makes 3x to the third power. Looks a bad 3 there. And then I have 3x times 5, 3x squared times 5, which is going to be 15x squared. Then I have negative 7x times x, which is a negative 7x squared. And then a negative 7 times 5, which is a negative 7x, which is a negative 35x. And then our last terms here, we have our, negative 10 times x, which is a negative 10x, and negative 10 times 5, which is a negative 50 there. So now get my like terms together. So I have a first one here, and then my second is going to be that set there. So I have 3x to the third, and then I get 15x squared minus 7x squared, which is going to be a positive 8x squared. Then I have a negative 35 minus 10x, so those two can get together. So that's a negative 45x, and then a negative 50. There's nothing that can get with. So here it's a little bit confusing because when you start adding and subtracting, you have to look for like terms. Those are only ones that you can add or subtract, and you're not going to add or subtract the exponents. Remember, that's if you're multiplying or dividing. So a key thing that I've kind of been telling lots of students is that if the coefficients are following a certain rule, the exponents will not follow that same rule. So it's kind of sort of something that you definitely want to keep in your head, is that if you're working with an exponent or a coefficient, if you're working with a coefficient, it will follow the same mathematical rule. If you're working with an exponent, that's when they follow those exponent rules. So just some things to kind of wrap up. Remember that FOIL helps you multiply polynomials. So that, remember, is a multiple term expression. So with 3 terms, you have a trinomial. With 2 terms, you have a binomial. With multiple terms, you're going to have a polynomial. So basically what we have here, it's like double distributing. So that's what I kind of like to call it. So it's kind of like double distributing or triple distributing. And so you're just going to distribute that term to each term in the other set of the parentheses. So that's kind of something that you definitely want to make sure you take note of. And then make sure that you multiply each term. And then you'll kind of sort of start combining those terms. Not always will you always have like terms to combine. Most of the time, though, you will, especially those inside and outside. The O and the I part of it. Those will be the ones that you are going to multiply, or going to be able to get together. It's that first and the last term that typically, not always, typically you don't have anything to add or subtract there. So multiplying polynomials, you're following the FOIL or double distributing method there.